So velocity would mean what? Speed and direction both. So the magnitude of velocity is speed plus direction, because velocity being a vector, it has both magnitude plus direction. Now in uniform circular motion, speed is same. As per definition, uniform circular motion speed is same, but direction keeps changing because direction is always tangential to the curve at that point. Suppose this is the circular motion. The particle is going along a circle like this. At an instant when the particle is here, its velocity will be like this, tangential to the curve. When the particle is here, velocity is like this. When the particle is here, velocity is like this. When the particle is here, velocity is like this. So velocity is always tangential. So direction wise it is changing or not? So what can you say about velocity, whether it is constant or variable?
Variable.
Very good. So velocity is variable. Of course, it is varying only in direction, not in magnitude. Because velocity is always tangential to the curve at the position of the particle. Is it clear? So as we have learned, if the velocity changes, there has to be acceleration, because as per definition, acceleration is the rate of change of velocity. So whenever velocity changes, there has to be acceleration. By acceleration we mean linear acceleration, because we are talking of linear velocity here. Linear velocity changes means there has to be a linear acceleration, isn't it? So linear acceleration will be there. So usually what happens is, the velocity can change either in terms of speed or direction or both. Is it clear? So if the velocity changes in speed, that is in magnitude, then the corresponding acceleration is known as tangential acceleration. Tangential, because it is along the tangent in the direction of velocity. Okay? If speed increases, acceleration will be in the direction of velocity. If speed decreases, it will be opposite to the direction of velocity. But anyway, it will be along that. But when the velocity changes in terms of direction, then the corresponding linear acceleration is known as centripetal acceleration. Centripetal acceleration, also known as radial acceleration. Centripetal means center seeking. It always seeks center. It is always directed towards the center. It is also known as radial because it is along the radius. From the particle you join the center, you get the radius. So as we'll see, centripetal acceleration or radial acceleration is always towards the center. Hence the name centripetal acceleration. And here in this case, since we are discussing uniform circular motion, we are discussing uniform circular motion, isn't it? We are discussing uniform circular motion. So speed is constant. So we don't have any tangential acceleration here. We don't have any tangential acceleration. We only have centripetal acceleration as a result of change in direction, centripetal acceleration. So let us find a formula for centripetal acceleration. Okay? It is also known as radial acceleration, as I told you. But more commonly it is known as centripetal. It is a linear velocity, not an angular velocity, angular acceleration. It is a linear acceleration. It is because of a change in velocity. Right. So let us say that at any instant, at an instant t, it is here. Initially it is here. Sometime t, the particle is here. P is the position of, or P naught is the position of particle. Then during a small time interval dt, let us say it comes to position P1. Meanwhile, the time elapsed is delta t. That is, now the time is t plus delta t. Particle has reached position P1. Okay, it is moving with its speeds v, constant speed v. So it came from P0 to P1, thereby the radius vector joining the particle describes an angle delta theta. It has described an angle delta theta. Is it okay? So now you see, try to understand. Now the velocity will be tangential to this, isn't it? So initial velocity I take v1, final velocity I take v2, speed I am taking v. That is magnitude of velocity I am taking v. But since velocity as a vector it is changing, so I have to use different notation. The initial velocity I am denoting by v1, and at this point of time final velocity as v2. Now if you recall the definition of acceleration, it is the rate of change of velocity. Rate of change of velocity is the what? Acceleration. So by definition it is delta v by delta t. Okay? Moreover, it's a vector equation. So the acceleration will be directed in the direction of change in velocity. Because delta t is a positive scalar, we discussed. Delta t is always a positive scalar because time always increases. So when anything increases, change will always be positive. So when you divide or multiply a vector with a positive scalar, the resulting vector will be in the same direction as the delta v. So here acceleration vector is in the direction of delta v. And also we'll calculate the value also. Value, and first let us calculate the value. So delta v, let us find delta v vectorially is final minus initial. Here we have taken final velocity as v2, initial velocity as v1. You know vector subtraction is a special case of vector addition. Yes or no? So it is basically vector v2 plus negative of vector v1. This vector v2. This is vector v2 and minus vector v1 is this. Do you agree? Vector v1 is like this. This is plus v1, so minus v1 will be down. So we started from here and this is the final point. So join them by a straight line. This is the change in velocity v2 minus v1. Vector v2 minus vector v1. Do we agree? So acceleration is in this direction. Acceleration will be in this direction. The direction is clear. Right. Now coming to numeric value. Numeric value it is this. Remember this length we have to find. Now you see angle between v1 and v2 is delta theta. Because v1 is perpendicular to this and v2 is perpendicular to this. So since this radius vector turned by delta theta, velocity vector will also turn by same delta theta. So that means this angle is delta theta. This angle is delta theta. So remember this is an isosceles triangle because the lengths are equal. Why lengths are equal? Each of the length is equal to speed. Speed is same. Speed remains same. So each of the length is v. So it is an isosceles triangle. These two sides are same. So when you drop a perpendicular, then you divide this into two congruent triangles. In an isosceles triangle, when you drop a perpendicular from this vertex to the other side, you are basically dividing it into two congruent triangles. Congruent means duplicate. In movies and all you see, two Shah Rukh Khans will be there or two Ram Charans will be there. I don't know whether Ram Charan has any movie in which he has double role, I don't know. It is there? I don't know. Anyway, Chiranjeevi, lot of movies are there. Even Bollywood, lot of Amitabh Bachchan double roles are there. So there what we say, Kamal Haasan also. There what we say is the duplicate. Same to same. So general word is duplicate, but mathematical word is congruent. So congruent means duplicate. So two same to same two triangles we get. So that means these two angles will be same. So each of them will be half of delta theta. And this length below it is v. This is a right angle. So in this right angle triangle with respect to this angle, this is perpendicular. Perpendicular is equal to hypotenuse into sine. This part. So this part will be v sine delta theta by 2. And total change in velocity is double of this because these two are equal. So this numerically it will be twice v sine delta theta by 2. The mod, the value. In vectors, value means length because length is proportional to the magnitude. Length is proportional to the Is this clear? So that I am going to put it here. So from equation 1, I have acceleration is numerically equal to mod of delta V by delta t. Mod is 2V sin delta theta by 2 upon delta t. Is this okay? Right. Now try to understand. We are interested in the instantaneous acceleration when the particle was crossing position P naught. Actually it came like this, it was coming like this, and as it was crossing, at that instant we wanted the acceleration. So that means delta theta is very small, and of course delta t is also very small. Because the more the time you allow, the farther will be P1 away from P naught. Do you agree? If you allow less time, P1 will be hardly away from P naught. P1 will be hardly away from P naught. So delta theta will be small, delta t will be small. Do you agree? All of you are convinced? Because we are interested in the instantaneous acceleration exactly while the particle was crossing this position. We don't want P1 to be far away from P naught. We want P1 to be extremely close to P naught. So under these conditions, delta theta will be very small. And you have already learnt in basic maths, when angle is very small, sine of angle is equal to angle itself. But angle should be in radian. For example, 1 degree is very small. You convert degree into radian. Sine 1 degree is equal to angle in 1 radian. 1 degree angle in radian. Small angle, sine and angle will be same. So that means what I'll do? I'll do like this. I'll remove sine. And angle is always in radian, that is understood. I don't have to specify that angle in radian. Angle is always in radian because SI unit of angle is radian. So now what happens? 2 gets cancelled. But delta theta by delta t is omega. Just now we saw angular velocity. Delta theta by delta t is angular velocity, omega. So we have this is the formula for centripetal acceleration v omega. Also, we learnt omega is v by r. Yes. So if we write this as v by r, then we will get this as v square by r. Also, v is omega r. So instead of v, we can write omega r. So it will be omega square into r. Now, the most important thing, all of you pay attention please. Try to understand that the more the time I allow, once the particle crosses the position P naught, the more the time I allow, the more inclined will be velocity V2 with respect to V1. Do you agree? Because exactly velocity V1 was like this. But if you allow more time, it will become more and more inclined. If you allow less time, it will become less and less inclined. Because we want instantaneous. So delta theta should tend to 0. Do you agree? Delta theta should tend to 0. Now try to understand, this is delta theta. This is minus V1. Minus V1 is fixed. But suppose if we allow lesser time, then delta theta will be, then V2 vector will be like this actually. This will be V2 minus V1. Then it will be like this. Okay? The direction of delta V will be like this. If we still decrease this, remember these two sides must be same because speed is not changing. So our delta V will be like this. If we still reduce this, it will be like this. And as delta theta tends to 0, it will be exactly like in this direction. Because, see, it is perpendicular to V1. Minus V1 is like this, so it's exactly. So as delta theta tends to 0, delta V will be in this direction. So centripetal acceleration is in this direction. Now you can see the acceleration is directed towards the center. Hence the name goes centripetal acceleration. Centripetal, center seeking. It is always directed towards the center. So at the instant of the, whenever this is the location of the particle where you want, join it with the center. That will give you the centripetal acceleration. So I hope you understood. As delta theta goes on increasing, this will exactly point towards this direction. So value is how much is? Direction is towards the center. That means when the particle is here, what will be the centripetal acceleration direction? Towards the center. When the particle is here, what is the direction of centripetal acceleration? Velocity is like this. Here, velocity is like this. Centripetal acceleration is like this. What is the angle between tangent and radius?
90.
So, at any instant, angle between velocity and centripetal acceleration is very important concept. Velocity is always tangential, and acceleration is always, centripetal acceleration is always radial. Perpendicular is also known as normal. Do you know? So you can also call this as normal acceleration. So different technical books, they will be using different symbols. In school books they will say centripetal acceleration. In slightly higher studies they will go for radial, and in technical studies they will go for normal acceleration. They will say normal acceleration. All are same, perpendicular to the velocity direction. Okay? Is this clear till here? All of you are clear about this? Anybody has any doubts?